Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a topic from unit commitment. The name of a topic is Introduction to the Unit Commitment and Need of a Unit Commitment. Now let's see, we know that the total load of the power system is not constant always. It always changes time to time throughout a day, and it will be reached up to a different peak value from one day to another. Let's see, this is a diagram. This is a load curve. If you see here, the maximum load will be in between 12 to 16, 12 p.m. to 16 p.m. Now it follows a particular hourly load cycle over a day. So there will be a different discrete load levels at each period. And that's why it is not advisable to run all the available units at all the times. If you see the requirement of the load here, or we can say the power requirement from, let's say, midnight 12 to 4, it is less. So it is not always required to run all the units which are available with us. On the other hand, if we see in between 12 p.m. to 16 p.m, the requirement of the power is more. So in this situation, we have to run all the units. Now we have to take certain decision whether to turn on or turn off that particular unit. It is necessary to decide in advance which generators are to be started and when to connect them to the network, the sequence in which the operating units should be shut down, and for how much period. So therefore, one can define this process of unit commitment is nothing but it is the computational procedure for making such decisions, and a unit when scheduled for a connection to the system is said to be a committed. So therefore, we can say that the problem of unit commitment is nothing but to determine the units that should operate for a particular load. To commit a generating unit is nothing but to turn on, that is to bring it up to the speed, synchronize it to the system and connect it so that it can deliver a power to the network. Now, we can define a unit commitment in another way also. It is defined as the scheduling of a set of generating units to be on, off, or in a standby or a banking mode for a given period of a time to meet a certain objective. Now, if you see here, turning on and turning off is nothing but a commitment. Please remember, when we discuss about a unit, then unit is nothing but it is the combination of boiler plus turbine and generator. So please remember, this is not a unit, whatever we can say, I have used 1 unit of power and 2 unit of electricity, like that. It is not like that. Here, this unit is nothing but combination of boiler, turbine and a generator. Now let's have a discussion about what is the need of unit commitment. Before that, we will discuss what is the comparison of unit commitment with economic load dispatch. Now, as we have seen earlier, economic load dispatch, we can define it as, I write it here, ELD, economic load dispatch. It is nothing but simply I can say dispatching load economically. So it distributes the actual system load as it rises to the various units that are already online. However, the unit commitment problem plans for the best set of the units to be available to supply the predicted or the forecast load of the system over a future time period. So this is what is the difference between a unit commitment. If I have, let's say 10 generators, so within that 10 generators, if I distribute total load and I have arranged it on the basis of cost of a generation, so that there should be a minimum cost of a generation, then we can say it is economic load dispatch. Whereas for that particular period or for that particular load demand, shall we turn on all the units or only 4 units, only 5 units? That decision is related to the unit commitment. Now let's have a discussion about need of unit commitment. Now, the planned commitment and the unit ordering schedules extend the period of optimization from a few minutes to the several hours. We know that there are few patterns of the load, few weekly pattern. Now, how we can decide the weekly pattern? It is based on daily schedule. Likewise, from weekly pattern, we can prepare a monthly pattern. From monthly pattern, we can prepare a seasonal and annual schedules that can be prepared by taking into consideration the repetitive nature of the load demand and the seasonal variations. Now, a great deal of money can be saved by turning off the units when they are not needed for the time. Let's say, suppose demand is not so much, then is it possible to run only a few units so that there will be, we can say, no fuel cost will be more in that situation? So therefore, this decision has been taken with the help of a unit commitment. If the operation of the system is to be optimized, the unit commitment schedules are required for the economically committing units in the plant to service with the time at which individual units should be taken out from or returned to the service. Now, this problem is of importance for scheduling the thermal units in a thermal plant, as for other types of generation such as hydro and their aggregate cost, such as, let's say, startup cost, operating fuel cost and shutdown cost are negligible, so their on-off status is not so much important. So in short, we can say that why the unit commitment is required. First point is sufficient units will be committed to supplying the system load. If the more the load, so I will write it here, more the load, then turn on more units. Turn on more units. On the other hand, if the load is reduced to some extent, then take a decision in such a way that which unit should be turned on and which unit should be turned off. So what is the major advantage of this? The major advantage is related to the fuel cost. The fuel cost will be reduced. Now, next is to decrease the loss or the fuel cost. Yes, that's what we have discussed earlier. Third one, by running the most economic unit, the load can be supplied by that unit functioning closer to its best efficiency. What is the meaning of this? Let's say, suppose there is a one particular unit, and if the load is not sufficient, so if we run this particular unit, and if the power which is taken from that unit is only up to, let's say, 40% of that total capacity of the unit, then can we say that that unit is efficient? No, we cannot say. So for that case, some calculations has to be done in such a way that how much load is there, on the basis of that load, how many units should be turned on, so that we can achieve the efficiency or the best efficiency of the unit can be achieved with the help of unit commitment. So this is what is the basic concept of a unit commitment. What is the need of a unit commitment? Thank you for watching this video. If you have any doubt, feel free to ask the questions. Thank you.